volume of prisms and cylinders. So let's go ahead and say do this here today. And again, you will need your calculator out to go with it. Okay? There's notes. I don't know if I have any extras. It's the same pack of notes, so we can use them. All right, so let's get going here. Let's talk about today's stuff. And what I do with that? We are talking about prisms and cylinders, and well, that's volume. Okay. So volume is a space that a figure occupies. As you sit there, take up space, that's volume. All right. So volume is three-dimensional. We've been doing one-dimensional, two-dimensional. Length is one-dimensional. Perimeter is one-dimensional. Okay. Inches, feet, centimeters, meters, yards, miles. Then we get to area. That is, paint. That is wallpaper. That's flooring. Inches squared, feet squared. That's two-dimensional. And then we get to three dimensions. And three dimensions is all cubic. Okay, cubic centimeters, cubic inches, cubic feet, cubic yards, whatever the case is. Now, with that, let's find our formulas today. Now, when you look at your formula sheet today, right now we're talking about a prism. And when you look at your formula sheet for the prism there, now, down there, as you can see on the second row, we've got our five main solids. Five main solids there. Now, the prism that we're talking about, they only give you one prism on there. They give you a rectangular prism. Now, we're going to do more than just a rectangular prism here today. We're going to do, how many prisms did I just rattle off yesterday? We have a triangular prism. We've got a pentagonal prism. We've got a hexagonal prism. We've got a cube. We get all different types of prisms, just change the base. But all they give you is a rectangular prism. So what we're going to do is talk about a general formula, and then we'll focus on also using your SAT formula sheet. But in general, the way that we go about finding volume is this right here. All right, so how we go about finding volume is starting with area. Okay, we all know how to find area. So area is a nice two-dimensional surface. We can find the area of, what shape is that? It's a rectangle. How do we find the area of a rectangle? Length times width, base times height, right? So whatever the base is, we take the area, and then what is volume? Volume is space. So I start to create height to it. And as I start to create height to it, again, we start to create space. So I create a whole bunch of areas and start stacking on top of it, and as I start to create that height, that is where your formula says length times width times that height. That's how we're creating all these formulas, all right? So volume is, again, length times width times whatever that height is. That's where these formulas are coming into play at. So whatever the area of the base is times that height, that is how we create our formulas for volume. Now, our general formula that we use, our basic formula is this. Volume of any prism is capital B times H. Capital B times H. That's not what your SAT formula sheet says, because your SAT formula sheet says only only the volume of a rectangular prism. But there's an infinite amount of prisms out there. So we think big picture. Capital B in math, in geometry, capital B stands for area of the base. What shape is the base? Could be a triangle, could be a rectangle, could be a pentagon, could be a square, could be a hexagon, whatever. And then that little h right there, little h in geometry, it depends on what you're focusing on. If it's volume, little h usually represents the height of the prism. If we're in area, area usually represents the height of the polygon. Okay. Now, let's go and start just using our formula. Okay. So depending on what prism that you're focusing on, that capital B times H kind of changes depending on what shape the base is. All right. So let's just start off with the basic as it is. First thing you gotta know is what solid are you dealing with? What prism are you dealing with? Are you dealing with a rectangular prism? Are you dealing with a pentagonal prism? Are you dealing with a triangular prism? It all changes based off of the shape of the base. So on number one, well, what's the shape of that base? The shape is a rectangle. So what we have here is a rectangular prism. Okay. Again, the reason why we call that a prism is the top and bottom base are congruent shapes that are parallel. Now, I know it sounds silly because this is as simple as it gets, but they're not going to be as simple. So what we always like to start off by doing, and one of the things, again, we've tried to talk through about you guys throughout the school year, is when you use distance formula, midpoint formula, know the formulas by writing them down. So that's what I'm going to do. We're talking volume of a what? Prism. Area of the base times the height. Capital B times H. Now, I'm going to change what that capital B is. The B changes to whatever the shape of the base is. What's the shape of the base? You told me it's a rectangle, so what is our formula for rectangle? Now, I don't like it as much, but we'll do it because that's what SAT does. L times W. I like to use little b times h, base times height. Now, what's the dimensions of the base? What's the dimensions for the length and width? It's 5 by 8, isn't it? And what's the height? The height represents the height of the prism. So what's the height of my prism? Height is 3, isn't it? And then it's just a quick, go to your calculator, but you don't even need a calculator here, do you? 5 times 8 is 40. So we have the base's area. And then it's like we're stacking a whole bunch of 40s on top of each other to create that height, and therefore we create volume. And what is it? 40 times 3 is 120. Units are inches. Correct. Inches cubed. I know I took a long route way to that, but that's what we do because these bases change up on you. And let's go with the next one because we don't have a rectangular prism. What do we have here? We have ourselves a triangular prism. So anytime I see that, I always start off with area of the base times the height. Now look at your SAT formula sheet. Where does it say the formula for a triangular prism? It doesn't have a triangular prism on there, does it? Okay, so we have to modify the prism's formula. We're not using length times width, are we? What's the shape of that base? You said it's a triangle. So let's go up top to that top row. As we work throughout this school year, how do you find the area of a triangle? Area of a triangle is what? 1/2 base times height. Okay. Whatever the shape of that base is, that replaces that capital B. I keep using that parentheses to hopefully draw your attention to that's what's replacing that capital B. That's what's replacing that capital B. Now I got 2 H's in there. Who cares? That's what we're focused on depending on what formula we're using at the time. Now it's not quite the same triangle. That's the only triangle I got here. All right, we're focusing on right now the triangle at the moment. So when I look at this triangle here, we want to go ahead and find the area of that triangle. It's a right triangle. Makes our life easier. With that right triangle, look at that triangle. I've got a 6 and a 10. We want to make sure that 6 and 10 are perpendicular to one another. Are 6 and 10 perpendicular to one another? Yes or no? Are 6 and 10 perpendicular to one another? Here's the 6. Here's the perpendicular. Are 6 and 10 perpendicular to one another? I don't think so. 6 and 10 are not perpendicular to one another. So, go find me what's perpendicular to that 6. How can I go find what's perpendicular to that 6? Oh my God, Pythagorean theorem. Exactly it. Okay? It's never going to go away. So, go find me what's perpendicular to that 6. It's right triangle, Pythagorean theorem, and we don't even need to use it because it's a 6, it's a 10, and it's a 8. It's a 3, 4, 5 in disguise. So, that 6 and 10 are not perpendicular to one another. We use Pythagorean theorem. Base of 6, a height of 8. Now, that's solely for the area of the triangle. All I did was find the area of that base. Now, what is the height of the what is the height of the prism? What's the height of the prism? What is it from base to base? 9 millimeters. From base to base, that H on the outside there, it's all about the context of things. That is representing the height of the prism. There we go. Attention to details, people. All right, now let's go punch it into our calculator. Now we can do that in our heads mostly. 6 times 8 is 48. Half of 48 is 24. And maybe 24 times 9 we might want to do there. 24 times 9 is 216 millimeters cubed. Okay? Rectangular prisms, there's nothing to that. It's pretty impossible to screw that up. After rectangular prisms, that's where the really work comes into play. Okay, let's go to the next one. We got ourselves a prism, a special type of prism where it's our good old cube, right? Okay, on that cube, one thing we know about cube, we talked about yesterday, is we know all these sides, all the edges of a cube are congruent because it's a square all around. What we got here then is the volume of the figure is given to us. We want to work it backwards some way, somehow, such that we can figure out what is the edges. Okay, so let's use our formula for a prism. How do we find the volume of a prism again? Who cares if it's a cube? A cube is a special type of prism. All right, let's think about this. What's the shape of the base of a cube? It's a square. How do we find the area of a square? What's up? A squared, S squared, same thing, right? It just so happens the base is A in this case. Sure. Now, what is the what's the height of this cube? What's the variable they're using still? A. All right, let's go back to like 6th grade. What's A squared times A to the first give you? A cubed. That's your exponent skills. This is what we call our product rule from 6th grade. A cubed equals given volume. So now I'm asking you a cubic. What times itself 3 times gives you 729? Okay, so if I take 243 to the 3rd power, because that's what we're doing, do I get 729? That's what that tells me. Ooh, just a little bit off. Okay, just a little bit.
Oh my gosh.
So that's what we were doing. Okay, just a little bit. All right, no problem. Okay, Sam, what were you going to suggest? Sam is suggesting 9. Okay. Now, how we get into that? We cube 729. Now, let's think about this going, how we can solve this out algebraically. All we're doing is inverses. We've got inverses galore. Multiplication undoes division, addition does subtraction, square roots undoes squares. So what undoes a cube? Cubed root. So what I want everybody to do is on your calculator, take the cube root. Go find me the cube root on there. Let's go use the new button on your calculator today. Okay, the cube root, look on your calculator. Where is that cube root on your calculator? If you're going to Algebra 2 next year, is anybody going to Algebra 2 next year? Oh, everybody is. That's right. So you better know this. Okay, I don't see on my calculator the cube root button. So it's hiding because it's not for all of our purposes up through Algebra 1 and geometry. It happens, but not very frequently. Algebra 2, you better know it. Okay, right here, that math button. We've used that math button here pretty frequently to change decimals over to fractions, right? Let's click it again. Okay, it's a pretty frequent button, so they put it up fairly high. Option 4, right? Option 4 is the cube root. So hit option 4. And there it is, the cube root of what? 729. So the ones that are not as frequent, they hide underneath math, and it's up kind of at the top. Okay? And the ones that are most frequent, they put as on the quick view right there on your actual keyboard. Second options are the other quick ones that are just hiding right there. Hit enter, and that's what your calculator is doing. 9 times 9 times 9 is 729. So what that tells us is the side of this cube has got a length of what? 9 centimeters. Okay. I know it's a roundabout way getting there, but you all can do square roots like that. We've done that throughout the school year. Cube roots are not as quick off the draw. Okay. So there we go. And next year, we're going to talk about how you simplify cube roots and fourth roots and fifth roots with and without variables. That's next year, but there's nothing with that. If you can do square roots, you can do cube roots the exact same way. Instead of doing, and we've even talked about that. Instead of looking for pairs, you look for what? Triplets or groups of 4, groups of 5. Don't overthink. Carry on what we've been doing this year. All right, let's go to the next one. Okay, what we have here is a rectangular prism with a bit of a, again, Michael Jackson lean to it. Okay, we have a cylinder, which we're about to again give a bit of a Michael Jackson lean to it. What do we call those? We call these obliques. An oblique prism, an oblique cylinder. We're going to give it an oblique pyramid, an oblique cone later on. It does nothing to the volume. It does nothing to our formulas. We're going to do the exact same thing. Area of the base times the height. All right? So I can't do that. Michael Jackson lean, neither can Michael Jackson. Do you know again what he did with that? He had special shoes and nails in the floor. He would do that, and then he's got some great ab work and leg work. That's how you get his Michael Jackson lean there. Okay, so just a nice trick there.
I don't know why I'm talking about Michael Jackson.
I don't know. I always think when I do the obliques right here, that's where it's at. Anyway, I guess I got to find some different stories for Alex then. All right, so let's transition then to finding the volume of a prism is exactly about finding the volume of a cylinder. All right, text Naeem on that one there, Alex.
Yep.
All right, good. So we got the cylinder going. Finding the volume of a cylinder is exactly like finding the volume of a prism. So on that cylinder, we are going to do the exact same thing. Area of the base times the height. It's the same formula. Who cares? What's the shape of the base? How do you find the area of a circle? That's way too long. I know. Pi r squared. So it's whatever the shape of whatever the shape of the base is. Okay. So that's this formula right here that we keep taking, area of the base times the height. We're going to keep using that today, tomorrow. We're going to modify it ever so slightly tomorrow, but that's the shape that we keep doing. Whatever the base is, take it times the height. If this is a triangle, 1/2 base times height. If it's a rectangle, length times width. If it's a circle, pi r squared times the height. Look at your SAT formula sheet. What do they say for a cylinder? Pi r squared times h, don't they? Okay? That's amazing, I know. Okay? So, with this one right here, there is our oblique cylinder then. So this is again where those bases are not directly one above the other. Okay. Well, let's go ahead and do the volume of an oblique cylinder. All right. On that cylinder then, okay, I always like to identify what we are finding what formula, what volume are you finding? Because as we'll see here, we will have multiple volumes happening in one problem. So identify what volume you're about to find. We're doing a cylinder this time, so tell me that out. What's our formula we're doing? Now the cylinder is only one base. It's only one shape. It's a pi r squared. Because it's a circle, you can just do that. Now if it's a prism, I usually start off with, let's see, that capital B times H. Now what's the radius here? What's the radius of my circle? 5. And what's the height of my cylinder here? 15. Yep, that 15 is straight down. It's got to be perpendicular to the other base. And as we can see here, as they drop that straight down from there, think about the Leaning Tower of Pisa. It's the same idea. Straight down. Okay? That straight down drop. And then we got a height of what? 15. And now we're right back to our circles from last week. In terms of pi and rounded to nearest whole number, go to your calculator. Do not put pi into your calculator. We all know what 5 squared is, 25. 25 times 15 is 375. Pi, and units are, what we just say, centimeters cubed. And then the directions say there, nearest whole number. Now we go back to our calculator, and 375 pi. Nearest whole number puts us at what? 1178, right. So make sure you're reading the directions carefully. Usually right here at volume, we do a lot of whole numbers. Area, a lot of tenths and hundredths. Volume, we do a lot of whole numbers. Also tenths and hundredths, but all that. Take number 5, let's do it backwards, I believe. Adeline?
I feel like I have this on the PSAT.
I would.
Question.
There's a solid chance you might on the sophomores 10th grade tests.
Like,
If you do, it's usually where volume would pop up. Yeah,
it was different numbers, but it was
definitely.
It was like that.
Yeah, I would think there'd be a good chance you would see a volume question on the 10th grade test. Probably not a ton, maybe 1 or 2 at most. But yeah, freshman not so much.
Yeah, with that, and then what is the diameter like? It's so weird. Like,
All right, so we're talking about a cylinder, so I jot down my formula. Okay, we are given the volume this time, so I'm going to plug in that volume in the right spot. And this is a working backwards problem like we've done. Now, we got the height, we're trying to find the diameter. Got to know what the radius is. So as we've, again, worked through backwards through the last week or two with, say, circumference, find the radius, find the area, or given the area, find the circumference. We've had to do those things. Same idea here. We're trying to solve for r. Got to get rid of pi in that 43. It's all attached by multiplication. And the inverse of multiplication we know is division. So we're going to divide by 43 pi. These pi's cancel. We go to our calculator. What is 9,675 divided by 43? 225. And this time we're solving a quadratic. The one we did up above a few minutes ago, the cube, that was a cubic. Here we're solving a quadratic. So square root both of these. And you should know what 225 is. 15. Correct. The silly mistake is to just circle the answer and move on. That's the radius. That answers part of the question, but they want the diameter. So the diameter is 30 meters. Okay? 30 meters. Nothing crazy on those, but make sure you read the whole questions off that. And we've done these work problems backwards before. Okay? Now, going back real quick to that cubic problem that we did. As you see here, when I took the cube root of both sides, this is what we call the index. When I put that 3 there, make sure you put that 3 there. If you don't put the 3 there, what that means is you're taking the square root, which we weren't. We'll do a lot more work with those next year. All right, let's flip it. Let's take a look at the back side then. Okay, on the back side, again, we're kind of running out of some time, so I want to make sure I get to at least number 8 down here. All right, we talked about revolutions yesterday. Okay. As we revolve this about the x-axis right here. As we revolve this about the x-axis, what I would again do myself is first do the reflection just to see an again idea of how that cylinder is being created. Is it being created on its side or is it standing tall? Because it does matter then of what radius and height you get. So when you revolve it about the x-axis, is that standing tall or is it on its side? It's on its side. So I would go ahead and just kind of bring that down to make that circle. All right. And in this instance, again, as you said, it's on its side. Okay. So we got ourselves a cylinder situated like that. So we got ourselves a cylinder. And then with that cylinder, again, I highly encourage you to jot down the initial formula that you're using and then identify the radius and the height. And if you don't have it going the right direction, if you're telling me it's standing tall here, your radius and height are going to be flip-flopped and it's not going to be the same. So what turned out to be our radius then as you drew in those circles? Our radius is what? Radius is 2 because there is our line of revolution going right through the middle. Our radius is 2 and our height is then what? 4. Here's our base to base, our circle to circle. Our height is 4. And you don't need a calculator here because they all say in terms of pi. So 2 squared is 4. 4 times 4 is 16 pi. We don't have units, so we say units cubed. Okay. Last one there says revolve about y equals 2. Let's go back to reflections when we did some work with the same idea. What does y equals 2 look like? Is it a horizontal line or a vertical line? Horizontal, vertical. So horizontal. Y equals 2 looks like that. Okay, so y equals 2 is a horizontal line. So we're going to revolve about y equals 2. So that means when we reflect that over, we get another cylinder that is sitting what? On its side, like that. Okay. And actually, what happens then? We're going to get the same volume, aren't we? Okay. I turned out to give you a cylinder that gives you the same volume, but I give you a different type of revolution. So when we revolve that around, in this case, y equals 2, it's kind of going back and making sure that you know what does y equals 2 look like. And again, we get what? 16 pi units cubed off that. Okay. Now, rectangles one more time are always going to give us cylinders. Now, I'm not going to probably, on the assessments, I'm going to keep them pretty basic. We have short time here. In future years, if we have the extra time, that's where Naeem, I think, asked from the homework yesterday, that one that gave you a cylinder minus a cylinder. I'd keep on with that, but I'm going to ask you just kind of the basics off there. All right, the time that we're losing then, it's not a big deal, but these last two here, it's just an oblique prism. We would do it again, same way we did the cylinder, nothing crazy off that. And then it's about that time of year, when your pool's ready, it's a composite figure, composite prism. I don't have a name for that, but on that one there, all we do then is go about breaking that into two prisms. Find the volume of the back prism and add that to the volume of the front prism and add the two together. No big deal. We've done that type of stuff before. It's the same idea. Okay. That's where we'll go ahead and pause it for our time's sake. And then tomorrow we're going to use that exact same formula, area of the base times the height. But then we will go ahead and apply it to a what?